We're going to take a look at a trend called ionization energy. And ionization energy, as you can see, is the amount of energy needed to remove an electron from an atom. And sometimes we want to take an electron away from one atom and give it to another atom so we can form a chemical bond. And we'll talk about that next chapter. But it takes energy to remove electrons from atoms because we have to break the attraction between that electron and the nucleus. So that amount of energy needed to remove an electron is called the ionization energy. And basically what determines ionization energy is the size of the atom. The smaller an atom is, the closer an electron in its outer energy level is to the nucleus, and the more attraction there is to the nucleus. So the smaller the atom, the more energy you're going to have to use to remove that electron. The bigger an atom is, the farther that electron is away from the nucleus, so you have to use less energy to remove that electron. So the ionization energy of an atom is all determined by the distance of that electron from the nucleus. The farther it is away, the lower the ionization energy. The closer it is, the more energy you're going to have to use. Here's a graph relating the first 20 elements, so hydrogen through calcium. And you can definitely see a trend for ionization energy. If we look at the trend between lithium and neon, as we move across a period from left to right, you will see that lithium has the lowest ionization energy, followed by neon, which is the highest. And as we go across that period, it's a general trend of increasing ionization energy. There are some variances in those trends, and those are differences between the orbitals that occur. And we'll talk about those a little bit later. Notice the elements with the highest ionization energy in each period are the noble gases, and those with the lowest in each period are the alkali metals, because the alkali metals in each period are the largest atoms, and the noble gases are the smallest. This is going to be a very important trend for us to know as we move forward discussing the periodic table. So the trend for ionization energy is exactly the opposite as what it is for atomic size. As the atom gets smaller, the ionization energy increases. So helium would have the highest ionization energy of any atom, and francium would have the lowest. If we go in to remove a second electron, we call that the second ionization energy, and it always takes more energy than the first. And if we want to remove a third electron, it's called the third ionization energy, and that one is greater than the first and of the second. So basically, every electron that we go in to remove from an atom, it requires more and more energy. Because theoretically, we're taking an electron that is closer and closer to the nucleus. Let's look at magnesium, for example. If we look at the ionization energies for magnesium, we see that the first and second ionization energies are relatively low. And then we go to remove that third electron, and there's a huge jump in energy. It'll give up those first two electrons fairly easily, but that third one takes a tremendous amount of energy. That's because magnesium wants to achieve a noble gas configuration. Magnesium wants to be like neon in terms of its electrons. And in order to be like magnesium, in order to be like neon, magnesium has to give up 2 electrons, which it'll do. But then that third electron is going to require a lot of energy to take out, and usually it doesn't lose that third one, because at that time it's got a full energy level. It has 8 valence electrons. Aluminum, on the other hand, has 3 more electrons than neon. So aluminum is more than willing to give up 3 of those electrons to be like neon. But then that fourth one comes at a huge cost. So aluminum will generally give up 3 electrons and form what we call a +3 charge. Here's a visual diagram to look at ionization energy. We can see helium's the highest. The nonmetals are generally higher than the metals. The next trend we're going to look at is called electron affinity. And the word affinity generally means, to like or love something. And so this is a measure of how much an atom likes electrons. And it's technically the energy change associated with adding an electron to an atom. So if an atom likes electrons, it's going to have a high electron affinity. Doesn't like electrons, going to have a very low electron affinity. Nonmetals generally have a high electron affinity because they are smaller atoms. And it's easier to add electrons to smaller atoms because they're more attracted to the nucleus. Nonmetals need to gain electrons to become like noble gases. So they want to gain electrons to get that full energy level of 8 electrons. Metals give up electrons, nonmetals take electrons. So nonmetals have a high electron affinity, metals have a low electron affinity. As we move left to right across the periodic table, electron affinity increases because the atoms become smaller. As we go down a group, the electron affinity decreases because atoms become bigger, so those electrons are farther away from the nucleus, less attraction. Ionization energy, electronegativity, and electron affinity all have the same trend. They all increase up and to the right of the periodic table, towards the nonmetals, towards the smaller atoms.